Discuss very briefly. That is the construction of a transformer. Construction of a transformer. We are talking about mainly single phase transformer, but this construction, the materials we will be discussing, the things will be same for three phase transformer also. Just I will touch upon the things. What are the basically the different parts of a transformer? Different parts are different parts. One we know already, that is the core. Laminated, we say laminated steel iron, silicon steel, or laminated silicon steel core. So this is, we already know, the transformer core is basically laminated, and stamp links or each laminated strip size is generally 0.35 millimeter to 0.5 millimeter, and they are laminated. That means they are actually insulated from each other. The insulation is used normally, either they are coated by zinc oxide, ZNO, that is zinc, ZINC, zinc oxide, or it may be used varnished. It is varnished. Okay. And second is the primary and secondary winding. Primary and secondary winding. These are generally copper wires, and they are also enameled, like they are also insulated. Enameled or varnish is used to insulate the wire from the core. So they are electrically insulated. Like if this is the, suppose this is the transformer core and this is the wire. So this wire is basically insulated from the this iron core. This is not electrically connected. So if someone, if supply is given here and someone touches this person, but then it is not electrically connected, you will not get shock, or if you use a tester or voltage, you will not get any voltage. So this is the basic requirement, basically transformer, that this primary coil is insulated from the iron core. Again, the secondary coil is insulated from the iron core. Primary is insulated from secondary. They are actually isolated, electrically isolated. Okay. Already 1, 2, 3. Third part, we can say the housing. Basically, large transformers are housed in a big airtight tank, and maybe there may be different type of cooling of transformer. Depending on that, there may be some transformer oil, or it may be air cooled, some blower, fan, etc. may be used. We'll discuss a bit about that. And another thing is, this housing is basically the outer box, basically the tank where it is. We'll see this later. And another part is the bushing. Bushing is nothing but the external contacts, from two contact from the primary, two contact from the secondary. These are taken out of the box using some porcelain insulating material, that is called bushing, to connect to the outside circuitry. And another thing is, some external accessories are required for transformer oil cooling, etc. That is, one of them is conservator. We'll discuss about this when we'll discuss cooling. 6 is breather. Let's say, actually conservator is this one. Outside the tank there is one small tank, you can say, that is connected using two pipes, and how it is half filled basically by using transformer oil. So that is conservator, and breather is connected here basically. It is used for actually soaking the moisture from the air. Some air is there in the transformers, then so that the moisture content in the air doesn't get in or get out. So there is some silica gel is placed, silica gel that actually takes away the moisture content in the air or in the oil. That is known as breather. And other than that, some measuring device like a temperature gauge to measure the temperature rise of the transformer, some oil gauge. This oil gauge is used to measure the level, oil level, you can say. So if it is below the threshold level, then we need to put in some more oil, or may need to stop the transformer from the we have to remove the transformer from the circuit. And some relay is also used, very important. This is at least you should know the name of the relay. This is called Buck-Hole relay. This is basically a gas operated relay. This is used this in this portion. In the middle, the conservator is connected to the tank, and in the middle this Buck-Hole relay is connected. Other than this, and this is actually this relay identifies any presence of any gas in the transformer oil, and if some serious fault occurs, then this gas produced, and in that case this relay actually disconnect the transformer from the circuit. Other than that, one more thing is there important, that is radiators. This radiator part and conservator part we also discuss while we discuss the cooling of transformer. Basically radiators are outside the tank, something like these are given. So this is basically used to cool the oil, transformer oil, to dissipate the heat generated in the windings. So these are known as radiators. Okay, this is basically in a simple way the construction of large transformer. But now if we come back to the transformer core, construction wise, transformer core are of two types. Transformer core are of two types. One is called core type and another is called cell type. So basically what is the difference? Let us draw this. This will help to understand. In core type, the thing is already we have started with core type. So in this core type, what happens? This is the transformer core and windings are wound. Till now we have shown that this is primary and this side is secondary, but in practically when transformers are produced, or then for some practical advantage, what happens, both the limbs, this one and this one, contain primary and secondary both winding. Like first few turns of primary winding, or we can say first few turns of low voltage winding, basically low voltage winding in the both the limbs. Here also helps. First we give some turns of low voltage winding, then on top of it we give the high voltage winding, this way. This has certain advantages, and this is the high voltage winding. So both the limb contains primary as well as secondary. This is the low voltage. Generally, low voltage winding is given inside, and in the outside, first low voltage winding is given half here and then half this limb. Then on top of it, high voltage winding is done half here and then half here. So this outside one is the high voltage one. So there are certain distinct advantage of this, because if you do like this, then one important feature is that the first we have told that we need to insulate everything, like insulate the primary coil from the core, from primary coil to secondary coil with the core. Everything needs electrical isolation or insulation. Now if this is low voltage winding, then the insulation required between the core and the low voltage winding will be less. So first we have given the low voltage coil and less insulation required. Then once this low voltage winding is done on this side and on this side, then we put a very strong insulation, that is we call it high voltage insulation, to separate the low voltage coil from the high voltage coil, that is the separation between this and this. Then we wound the high voltage coil on both sides. So in this way we can save on insulation cost and insulation requirement. And another advantage of this is that the mutual flux will be more, or you can say the leakage reactance, the flux component that goes out of the, that does not link to the other coil, that will be reduced, much reduced, because the high voltage is, coil is outside and low voltage coil is inside, so flux linkage will be more. So we have leakage reactance, very reduced leakage reactance. And another advantage is that is from the perspective of maintenance. If some fault, generally most of the fault occurs in the high voltage winding, because low voltage winding doesn't actually doesn't have many number of problems or faults. Most of the fault occur in the high voltage winding, and so the repairing is very easy, because only the last final insulation is to be removed and their repair has to be done, then again this is put. But if it was other way around, the high voltage is in the below, then you have to remove, or we have to take away the high cost high voltage insulation to repair. So in that way also this type of construction helps. And this is basically used for, this core type transformers are normally used mainly for high voltage, when secondary voltage is very high voltage but small output. KVA rating is small, but voltage, the secondary voltage is very high, because this helps, this from this portion is high, so this portion provides higher insulation. And one more important advantage of this is that it could be air cooled, because there is very much gap, so air could pass through this, and this air could take out the heat generated in the windings. So in that way, it is helpful when we compare it to the cell type. How the cell type is looked. Cell type is something like this. In cell type, there is a central limb. This is the central limb. And what happens? The primary and secondary, these are wound like this. Primary, and this is the secondary. Schematically it is shown like this, but here also basically primary then secondary, or we can say low voltage, then on above the high voltage coil is wound. Like if we draw another, then here also this then again another one, the same way here we have done. Only difference is that here this flux generated is have two magnetic path. One path is through this, another path is through this. And advantage is that more flux path is there, and so leakage reactance is also here, also leakage reactance is reduced, and it requires less number of winding, less copper, less insulation than this. And it is mainly used when the output voltage is low, in low voltage but high output, higher output means higher kVA, okay, but low voltage. And this too provides low reluctance path to the flux. So due to more core material, the flux leakage is less. And as the coil is surrounded from both sides, this is mechanically more strong, robust, because the windings are covered from both sides from the core. This core is made up of steel, so strongly it is encapsulated inside, so it is in that way more robust. But the one big problem of this is that the cooling part is very not good. Here due to this space, air cooling is possible, but this case air cooling is not possible. So that is the basically two different type, port type and cell type, and the problems what happen in this both the cases. Okay, next we will be talking about the cooling of transformer in a separate video. Thank you.